Until now, we have looked extensively at the derivative of a curve, and you by now know that the derivative is the gradient function. It tells you about the gradient of a tangent to your curve. We're also going to be exploring the second derivative, which will tell us about the concavity of our curve. And even though we're not going to be applying higher order derivatives, we're going to investigate them a little bit in this video. If I want to find the derivative of this given function, then I would find f prime x, written as so. As this is an easy polynomial expression, I'm easily able to find the derivative by just using the power rule. In other words, I'm going to have 4x cubed minus 6x plus 1. Now you can see that this derivative is in fact also a function. So it stands to reason that I should be able to find the derivative of this derivative. When I find the second derivative, I can either write f dash dash x or f 2x, and that means the second derivative of the function of f of x. Finding the second derivative of f of x, I find the derivative of the derivative function. In other words, I'm now taking a look at the function which is given to me by 4x cubed minus 6x plus 1. So once again, just using the power rule, I find that the second derivative is going to be 12x squared minus 6. And you can see again that this is also a function. So continuing in this vein, I'm now going to find the third derivative, and the third derivative is going to be the derivative of the second derivative function. In other words, 24x. Looking for the fourth derivative, I find the derivative of 24x, which is 24. And when I get to the fifth derivative, I'm finding the derivative of a constant, and we know that that is always 0. Any derivative after the fifth derivative is still going to be 0. So therefore I must say that the derivatives, all bigger than the derivative when n was 5, is in fact going to be equal to 0. Now remember, I found the first, the second, the third, the fourth. So you can see that n, although greater than or equal to 5, must also be an element of the natural numbers.